All right, good morning. Got a great lesson for you to finish off the week.
Yay.
10-4. Inscribed angles and polygons. All right, we'll get through the lesson. It's a lot of slides, but it's not very difficult content, so I don't think it'll take too long. We'll see how it goes. Your homework is going to be using the BIM app tool just for today, just to keep practicing with that. The state test is multiple choice and it's online. It's some of it's fill in, but drag and drop, that kind of stuff. So every so often, we're not going to assign homework on the BIM app tool every day. But sometimes it's kind of good to check your answers and practice that. So that'll be the homework format tonight. All right, everyone has guided notes. Have you heard the word inscribed before? Inscribed. I bet you could piece it together. Do you know what a scribe is?
Yeah.
What is a scribe? I think back to old, way ancient times. Like a scribe would be someone that would write something down, right? So to draw or write. Thank you. And so to inscribe is to draw on. To write on. So draw on, not inside the circle, on the circle. So we need to talk about what does on the circle mean. Thank you. When we say on the circle, we're talking about the outer edge. On the circle is the outer edge of the circle. Are you guys listening?
Yeah.
I don't think we are.
Definitely.
Thank you. Outer edge of the circle. And so when we have an inscribed angle, it's not the angle that's at the center of the circle. It's the angle that's on the outer edge, along the circumference of the circle. So here we go. Got our inscribed angle. The vertex is on the circle. The vertex is on the circle. And then, just like every angle, made up of a couple segments, or lines, or rays. This time it's chords. There's segments that are called chords. Next fancy term is an intercepted arc. Fancy word, not that complicated. Okay, and your copies, I don't know how dark it came out. You might want to put your little pencil mark along that. I tried to highlight that for you in your guided notes, but it's that red arc right there at the bottom. That's called the intercepted arc. This is what we're going to be talking about all day. So, if you can draw or are given an inscribed angle, it kind of holds that arc, doesn't it? It points to it, and then the arc is the arc between them. It's called the intercepted arc. All points between where the chords touch the circle. And that next box, that theorem, we're actually going to discover on our own. Kind of. Is it okay if I scroll down a little bit? All right, so we got a circle. Quick little review. This is called the center of the circle. What was this called? What do we call that angle right there? This was the arc. What do we call that angle right there? If the vertex was at the center, we call it a what? A central angle. Very good. A central angle. Thank you. So the central angle, quick review. The central angle was blank. compared to its arc? Congruent. If the central angle was 40 degrees, the arc was 40 degrees. Do you remember this? Awesome. You just took a quiz on it. But, and I kind of showed you this already. Do you remember how I said, what if this vertex backs up a bit? Watch up here. What if it has the same arc? Tell me about what that angle's doing as it backs up away from the center. It's getting smaller. Do you all agree? It's not 40. It's less than 40. And what are we doing today? We're backing up all the way to where the vertex is on the circle. It's going to be smaller than the central angle. Okay? How much smaller? Well, I'm not going to get into the whole proof of it, but the angle, before you write this down, just look up here, okay? The angle is in red. The angle is half the arc, or the arc is blank compared to the angle. If the angle is half the arc, then the arc must be double the angle, right? You can look at it either way. Go for it. This is not for central angles. This is for inscribed angles, where the vertex is on the circle. The angle's half the arc. The arc is double the angle. Questions on that? So what if this arc were 60 degrees? What's the angle? 30 degrees. Easy. Okay, move on. Are we still writing? Thank you. All right, let's do an example here. Part A. The measure of angle T. Not arc, not an arc, an angle. So let's find angle T. How many angles are at T? Just one. Yeah, don't get tricky. It doesn't get too tricky right here. Just one angle at T. Bless you. Now, what you should do is look. Sometimes these pictures can get kind of confusing because there's a lot of segments going on in the same picture. Just look straight across. Say, okay, its arc is between R and S. It's called arc RS. So if the arc is 48, what's angle T? 24 degrees. Perfect. Letter B. The measure of arc QR. Well, QR is right there. And I don't see any angles. Oh, we haven't learned the word subtended, have we? Okay. I don't see any angles that hold that arc. Would you agree? So we have to think of another way to do this. Does anybody see it? It's kind of like a little puzzle. Can you? It's going to take a couple steps. Anybody see a process to get us there? What do you think, Paige?
Find the arc of QT.
I like it. Arc QT. Well, it goes with the angle of 50 degrees, doesn't it? So, Paige, what do you think this arc is? 100 degrees. The arc is double the angle. And then, what do you have to notice in the picture? What do you think, Ryan?
RT is the diameter.
Good. So everything on this upper half of the circle is how many degrees, Ryan? 180. And so the green part we're looking for must be 80. I don't know why I wrote that. Must be 80 degrees. So arc QR is 80 degrees. So you will have to kind of work your way around these circles a little bit, find some missing parts to get to an answer. It's not always just one step. Make sense to everybody? How to kind of work your way around that? Awesome. How about you guys try this one? It's really kind of find two measures, and then what do you notice about a couple angles there? All right, Josh, what'd you get for arc? R S.
60 degrees.
Good. Its angle that points to it is 31. The arc is double the angle, so 62 degrees. For most of you, it's going to be a very good habit to just take your pencil and kind of trace over either the angle or the arc you're looking for. It's going to keep things straight pretty easy for you. All right. Angle STR. By the way, on the quiz, some of us were getting a little lazy. We weren't putting arc symbols or degree measures for degrees and angles and stuff like that. Make sure you're naming these correctly. All right. I had to take off like half points on some people's papers, or 1 point if you kept doing it over and over. It might seem nitpicky, but if I say STR, you don't know if I'm talking about an arc or an angle, and now they're not the same, right? If I say STR, you're like, is it arc? Is it the angle? Because now one of them's half of the other, so be careful. STR is an angle, so you should look and say, where is its arc? Caden, what do you think?
31.
Well, yeah. So tell me. I'm sorry. What arc goes with that angle? SR. Very good. And that arc it was
62.
So the angle you said was 31. Half of it. Very good. Do you see that string of logic? They're both inscribed angles. They both share the same arc. They're congruent to each other. See it? So look for that. You're going to see that in a lot of problems where you're going to have overlapping arcs. Overlapping arcs. The angles are going to be congruent. So what do you notice about these angles? They are congruent because they share the same arc. It's almost like there's a theorem for that. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. And again, these pictures get kind of busy. You have to draw your eyes to what they're talking about. You guys want to hear the joke of the day?
Of course.
I asked, anybody in French in here? I asked a Frenchman if he played video games. He said oui. Yes, in French is continuous, but it's also a Nintendo.
That was funny.
So hard.
All right, so again, it's going to be a good idea to kind of trace these arcs. So angle D goes with this arc, angle C goes with that arc. Oh, look, the arcs are the same. The angles must be congruent. All right, find the measure of angle F. Well, here's F. Trace out its arc. Its arc goes from H to G. Agree? Its arc goes from H to G. Does everybody see that? Oh, look, this 75-degree angle. Its arc goes from G to H. What do you think, Tally? What's angle F?
75 degrees.
Perfect. See what I meant by this? This section will go pretty quick. Like, these problems don't take very long. Pretty straightforward. All right, next one. Find the measure of angle LJM. Again, great idea to trace, put a little arc mark at angle LJM. It's that angle right there. So what this is going to do, can you guys look up here for 1 second? What this is going to do, it's going to draw your eyes from making the problem too complicated. Like some people, I bet a lot of you would look up here at L and say, okay, there's an arc, and then M, there's an arc. Okay, those arcs are going to be congruent, and I need to do something else in the picture. Do you agree? Our eyes, some people in the room, their eyes might have been drawn to these, and then you want to overcomplicate it. But look at the angles you're trying to work with. Look at their arcs. What arc goes with J? LM, right? What arc goes with K? LM. It's those ones we're going to be working with. And since those arcs are congruent, we can say angle J and angle K are congruent. So what are we going to do? Set them equal. 5b minus 7 equals 3b. So we get 2b equals 7. So b is 3.5. We want to find angle LJM. We know they're congruent, so it actually doesn't matter which one we plug it into, but the measure of angle LJM is 5 times 3.5 minus 7. We can do this without a calculator. Are you ready? What's 5 times 3?
15.
What's 5 times a half? 2.5. What's 15 plus 2.5?
7.
Minus 7. 10.5. 10.5 what? Is it an angle?
Yes.
Yeah, it's an angle. 10.5 degrees. A little chilly.
Yeah.
Mental math. Now, an application of these. Inscribed polygon. That one's a pentagon. It could be anything. When all its vertices lie on a circle, all the polygon's vertices lie on the circle. The circle is called the circumscribed circle. Have you heard that one before? Yeah, you can giggle. It sounds funny. Too early? No? It's a healthy giggle. You need to get out of the way. Circumscribed. You good, Jackson? All right. Now you could have a circle where the polygon it's called the circumscribed polygon. Okay, and then what would be the inscribed part of this figure, the blue one? The circle would be inscribed, so it's the one inside. Over here, it was the polygon that was the one inside. Okay, this is not the one we're talking about. We're talking about where the polygon is inside of the circle. Now, let's think about it. What? Let's see. Pentagon's probably not the best one to do this with. Okay. We'll go on to some special cases. We'll have, I think the conversation's coming up a little bit later about a relationship inside the polygon there. All right, the next one. This is just a special case of ones we've been talking about. Is B an inscribed angle? Is B an inscribed angle? Is B an inscribed angle? Yeah, its vertex is on the circle. Yes, Tal.
It's supposed to say if and only if twice.
Yeah, I was thinking that.
Like if and only if and only if.
And Oh, an inscribed angle sometimes is a semicircle if and only if and
No.
No.
Yeah, there's no way think that's how much that doesn't sound like. Or it might say for
All right. So let's take a look at this special case. We know an inscribed angle is what compared to its arc? Half. And what's its arc? Its arc is a semicircle. How do we know? Because there's a diameter. Okay, so if the arc is 180, what's the angle? 90. That's just a special case. If an arc is a semicircle, then the angle must be 90. This is the one I wanted to kind of talk about a little bit more. The inscribed quadrilateral. This is only for quadrilaterals, by the way. Theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. If you're a fast writer, start thinking about why this is true. Opposite angles are supplementary. Anybody have an idea? Let me give you a hint. First of all, is angle F inscribed? Yes. What's angle F's arc? What's that?
EG.
E, D, G. If I called it EG, I don't know if I'm going that way. I better name it by its major arc name so I tell the reader I know which direction it's going. Does that make sense? Everybody agree? Angle F is that green arc. Now this theorem has to do with opposite angles in a quadrilateral. What's the opposite angle from angle F? D. Here's D. What's D's arc? EFG. EFG. What do you notice? What do you notice about the arcs? They make up the whole circle. I don't know if they're congruent. I can't say they're congruent. Do you agree? But they make up the whole circle together. That means they add up to 360. The angles are going to add up to 180 since they're inscribed. See it? The angles are half the arc. If the arcs make up 360, the angles make up 180. I can't say they're both 90. I don't know what they are. That's all I know. Now, how about these other ones? Ready? How about angle G? Isn't G's arc right here? And isn't E's arc right here? What do the red and yellow arcs make up? The whole circle. A different part of the whole circle, like different parts, but the whole circle. So the angles, those angles must add up to 180. All right. Here we go. We're trying to solve for x. Special case. Do you notice that C's arc is a semicircle? Now, be careful. What should we set 2x equal to? 90. Don't do 180. All right. Make sure you set it equal to half the arc. 2x equals 90. So x is 45. Degrees? No. Its arc is a semicircle, so the angle is going to be half of 180. X equals 45. Not degrees. It's not an angle. It's just the value of x. I can plug it in and get an angle. All right, the next one is if there's going to be a tricky one in this section, that would be the tricky one. Okay, this next one. It's not that bad. you have to piece it together. Actually, this one's not bad at all. There's some that are, we'll see if we have, I forget if I put any of the more challenging ones in this one or not. Yeah, I think I did. Okay, this is an easy one. Are the opposite ones congruent?
Yeah.
Not necessarily. But they are what, Christiana? Supplementary, right? So if this one's 80, what's angle Z? Sorry, the measure of angle Z. Z is 100 degrees. Y, well, what's supplementary to 120? 60 degrees. Now here I would put degree symbols on them because the letter is the measure of the angle. All right, and we're actually solve for that angle. All right, so you try slide. These are the ones, the one over there is just the one. It's a little bit trickier, but not bad. Just to solve for n. What orthodontist do you go to? What orthodontist do you go to?
The one we need inside.
Who is that?
I don't know. No,
Why are you getting an
attitude?
attitude with
You do have an attitude with me too.
My 11-year-old son needs to go to an orthodontist.
Spoonhouse.
Spoonhour.
No, it's not. It's the other one. It's the other one.
It's not.
The one that
Valiant.
Spoonhour is way better.
I like Brilliant.
My dad says all. My dad says all.
Where's that?
It's in green. It's like right next to
Literally right
the.
next to
Thanks for the information. I appreciate it.
Where did you go?
She's gonna get
You're the one that's not. No.
Oh.
That's why they've been on for this long.
All right, did you get Z equals 12 for our letter A? Double check my mental math. Questions on A? All right, letter B. Well, I think angle A, which is B degrees, is probably the easier one. How do we get B? Good, 180 minus 65, which is what? 115 degrees. A is a little bit trickier. And be careful, people. I can't tell you how many times people set these equal. All right. It's that virus that goes around this time of year. Okay. It's setting equalitis. And it's contagious. All right. Don't do it. You get so used to setting things equal. And it spreads throughout the room. But these ones do what? 3A and 111 do what? Add up to equal 180. 3A plus 111. Add up to equal 180. So subtract 111 from both sides. What do you get? What's 180 minus 111?
60. I don't know.
Just 69, right?
69,
Divide by 3?
23.
23. Now, just to be safe, I'd probably plug it back in. Well, we know what triple 23 is, 69. And those are supplementary, and then B and 65 are supplementary. This one is the little spicier one. Work together with your table partners to solve this one.
Okay.
Anybody who gets it right, it's a free high five.
You're gonna have to work fast.
I don't know what those are. If it's a pass to do homework, I'd be happy to give you one.
No, you should give out homework.
If it's a pass to be here during quiz days, I'd be happy to give one. Yeah, she's scared that you said she wouldn't give me any
But I forgot. And I thought you were gonna like say something about it. And now
Why not
I
send me?
I forgot to bring my notes.
Just spray her on the side of the room. Not just
Like,
like.
okay. Yeah,
Jared has a mask on.
Okay.
Do we?
I'm serious. I wanted to make sure I knew what you were doing
Ready?
before I said
90
How high?
plus
I'm not, so thank you.
45.
I'm being.
15.
Thank you.
90. Yes, it does.
Oh. I just got the virus. Did you do it?
I did 70. That's what I thought it was. I did it.
What'd you get?
Okay, K or 81.
What about the other triangles?
Sorry, I'm not being 50.
Hey guys, in case you haven't gotten through the whole problem, Olivia says we don't need to do all of it.
No, you don't.
There's one. My measures of GHG.
Wasn't there an attitude about it?
Find 4.
I got B, but I don't know how to spell it.
Oh. Okay, so the value that you have to eat is and that'll get you. What did I get?
Is that 15?
Yeah.
So this is
Oh, wait, yeah.
90.
70?
50.
Okay, I found the rest of them.
Yeah.
Yeah, it's one.
A minus 69. Is that 81?
Yeah.
And then 99?
Mr. Russell.
Check your answers.
Mr. Russell.
Yes.
All of them.
Oh, good job, Olivia. Did you want your free high five? Or are you good?
I don't know what G is.
I don't know what these are.
We should just print.
I can write you a pass to come take your makeup quiz for B or for A. Did you guys get these angles? Yeah. Any questions on these? Again, be careful. Do not set them equal. Add them up to equal opposite angles out to equal 180. All right, your assignment is on the B I
Online.
M app.
Then why does it say page? No, that's 38.
Because you put the questions on there.
What's wrong with Ben?
Here's what I would say. If there was something that went wrong with your internet at home this weekend and you need to do it out of the book, just do it out of the book. You know what I'm saying? Page.
So Liv doesn't have an excuse.
Say it again.
Oh, you fucking did.
I don't think I asked you a question because I'm ready. Once you've done that review, you're gonna have access.
How you going?
First, outer.
I know how to get all the numbers, but I don't know what to do with them.
I told you.
Oil.
You wouldn't even know that, so.
Yeah,
He just was like, oh yeah, you do this. And he went and then.
Okay, look at the X.
Distribute it. Oh, I know, it's very much.
They have
X squared plus 3X.
like a deep red.
I'm done with Jax. Look at the -5. Distribute it.
I didn't want to go, but then I wanted to go, but then it was too late.
Combine. Foiling, all foiling is, it's a distributed property, and it's another distributed property.
Run out or in the last.
Ella, we're not telling her about the quiz, are we? I know you wouldn't do that. She was gonna ask us.
Oh, sure.
Yes, please show your work from the homework on a separate sheet of paper. Unless it's like an easy, I'll be honest. Unless it's like it gives you darks 80 and asks for the angle.
What if
That's
we
40.
like use a draw tool on the?
That's fine.
Because I don't want to do something.
No, this assignment is on.
So you can do it on.
I'm asking you guys to do it on here tonight. The same problems from the book I assigned to you guys. It allows me to see what you guys are missing. So Emma and Paige, I guess that's one thing that from the teacher's standpoint. I see what you're saying about reviews on the homework stuff. I see students are all missing the same problem. And the students who will never ask a question in full class and we see, hey, you're missing it. I gotta see what they're doing.
My struggle was like, I feel like it's hard to go back and like try to even rework this process. You can just look at it.
I get that.
Do it on a second page, once on paper, it's not the same.